All right, welcome to the second video of converting from standard form to scientific notation. If you haven't already, go ahead and watch the first part. All right, so we're going to get straight into it, tackling some practice problems. I'm going to start with my left hand number 0.00782. Now, again, to write in scientific notation, I need to have a leading value times 10 raised to the something power. Okay, and in this case, I can't use this number as my leading value. It's not greater than or equal to 1. All right. So in order to do that, I'm going to need to move my decimal place until it reaches a point where I get a number that is greater than or equal to 1 and less than 10. So I'm going to, if it starts right here, I'm going to go 1, 2, 3. All right. And I want to use 7.82 as my leading value. So 7.82. Now the question then becomes, what is my exponent going to be? Okay, what number should I raise uh, 10 to? And in this case, if my number is 7.82 and I'm trying to get it back to this original number, again 0.00782, right? I need to be decreasing the 7.82. Right? I need to decrease it because 7.82 is currently greater than this value right here. All right. So if I raised this to the third power, write that a bit cleaner, then really I'd be taking 7.82 times 10 to the times 1000, I should say, right? Because 10 to the third is 1000. And if I do 7.82 times 1000, I'm gonna get a really big number, right? I need a small number. So then logically this needs to be -3. Again, just to back to old material, 10 to the -3rd can really be written as 10 to the third. Okay, so then in that case, I'm really taking 7.82 divided by, this would be 1,000. Okay, and if I'm dividing by 1,000, then of course I'm going to get a much smaller number, which is what we want because we want to get it back to the original number, in this case 0.00782. And we can test and validate our answer, right? So what I can do here is, if I have 7.82 times 10 to the -3rd, so I'm going to move my decimal place to the left, 1, 2, 3, fill it in, and do I get my original number? Yes, I do. So I'm good. All right, let's take a look at our next one. I've got 842,327. Right? Now, the first thing to do here, there's no decimal place, or there's no explicitly shown decimal place in this original number. So I'm going to go ahead and add that in, okay, right at the end of the number. Right? And so again, I like to set up what my scientific notation needs to look like. Some number greater than or equal to 1, less than 10, times 10 raised to some number. All right, now I definitely can't use 842,327 as my lead value, as that is way over 10. So I am going to scooch my decimal place, in this case to the left, 1, 2, oops, no, I lost track. 1, 2, 3, 4, 5. Okay, 5 places to the left, and I'm actually going to have to rewrite this. So I have 8.42327 times 10. Okay, raised to the, again, I need to get this value right here, 8.42327, back to this original value, 842,327. So I need to be increasing this lead number. I need to be increasing this number right here. So then logically, it needs to be a positive exponent. So again, 1, 2, 3, 4, 5 times 10 to the fifth. And if I want to validate my work, okay, what I can do is I can bring this in scientific notation back to standard form and see if my values match. So 1, 2, 3, 4, 5. So I'd have 8, 4, 2, 3, 2, 7 in my decimal place, 0. All right. And yes, indeed, it is matching up to my original value. These three, all of these three, they're equivalent. They're just expressed differently. I should say the first two. Okay, they're just expressed a little differently between standard form and scientific notation. Anyway, I hope you enjoyed this, and I'll see you in the next video. Thanks.